us see magnetic properties of materials. All the materials which we are using are not of the same type. They are different as far as its magnetic properties are concerned. Here there is a coil and it is connected to a battery. So then because of the current flowing through this coil, there will be a magnetic field. A specimen or a sample is kept in this field. Whether it will be magnetized or not depends on the type of the material. First you keep aluminium, then you keep iron. So different materials will be magnetized to different extent. So we have to see some parameters. First let us see magnetizing field. The magnetizing field is the magnetic field used to magnetize a sample or a specimen. A sample or a specimen is kept in a magnetizing field. So magnetizing field is the magnetic field used to magnetize the sample or specimen. Then whether it will allow the passage of the magnetic lines of force depends on this property, magnetic permeability. Then because of the current passing through this coil, there is a magnetic field. Then depending upon the material, there will be passage of magnetic lines of force. So let us see what is magnetic permeability. Magnetic permeability is defined as the ability of the material to allow the passage of magnetic lines of force, or the ability of the material to take magnetization. Then for free space, magnetic permeability is denoted by mu0. It is also known as absolute permeability. Absolute permeability, that is for free space, that is air or vacuum. Permeability is mu0. Value of mu0 is 4 pi into 10 raised to minus 7. Then relative permeability, it is mu by mu0, where mu is the permeability of the sample or a specimen. We are comparing the permeability of the medium to the permeability of free space. That is what's called relative permeability. Relative permeability is denoted by mu r. So relative permeability, there is no dimension, then there is no unit. It is a ratio of mu to mu0. Air or vacuum, that is for free space, relative permeability is 1. Next parameter is intensity of magnetization. You know that substances are made up of atoms. Atoms, at the center the nucleus, then electrons are in various orbits. Electrons, there are two types of motion, orbital motion, then spin motion. Then all the magnetic properties are due to electric current. So here electrons are in motion. So because of this orbital and spin motion, this electron will have magnetic dipole, it will acquire magnetic dipole moment. But this magnetic dipole moments are oriented at random. So net magnetic moment will be 0. But if you keep the sample or specimen in an external magnetic field, this magnetic dipole moments are aligned in a particular direction and it will acquire magnetic dipole moment. Then intensity of magnetization is defined as the ratio of magnetic moment to the volume, or intensity of magnetization is the magnetic moment acquired per unit volume. Magnetic moment is to be divided by volume. Magnetic moment is a vector quantity. So m vector is equal to, magnetic moment can be represented by Pm, then vector, it's a vector quantity. Then for a bar magnet, when it is, if a specimen is kept in a magnetic field, it will be magnetized. For example, iron is kept in a magnetizing field, so it will become a magnet. Now, magnetic moment is pole strength multiplied by the length of the magnet, so 2L vector. So it's a magnetic moment is a vector quantity. Then this is intensity of magnetization. Here this M stands for intensity of magnetization. Then this Pm vector stands for magnetic moment. Then if it is a bar magnet, volume can be written as area multiplied by the length. Length is 2L. If you are interested only in its magnitude, you can write like this. Qm, instead of 2L vector, you can write 2L, then A into 2L. 2L and 2L will get cancelled. So, intensity of magnetization is equal to pole strength divided by area. That is applicable for a bar magnet. Then magnetic dipole is measured in magnetic dipole moment. Magnetic dipole moment is measured in ampere meter square. Then volume is measured in meter cube. So 1 meter square meter cube. So it will get cancelled. Only 1 m will be there, meter. So ampere per meter. The unit of intensity of magnetization is ampere per meter. And the next property, magnetic induction or total magnetic field. A specimen or a sample is kept in a magnetizing field. When current is passing through this coil, there is a magnetic field. Now the specimen is in the magnetic field. Then total magnetic field is the sum of the magnetic field in vacuum and the magnetic field or magnetic field induced in the specimen. So B vector is equal to B0 vector plus Bm vector. B vector can be written as sum of these two. So B0, the magnetic field in the vacuum or free space, that can be written as mu0 H, where H is the magnetizing field. Then magnetic field in the specimen can be written as mu0 I, where I is the intensity of magnetization. When I explained the intensity of magnetization, I use the letter M. You can use I also for intensity of magnetization. Mu0 common, so you take it outside. So H plus I, where B vector is the total magnetic field. Total magnetic field B is equal to mu0 H plus I. Next property is magnetic susceptibility. Magnetic susceptibility shows whether it is easy to magnetize a sample or a specimen. Now in this magnetizing field, a specimen is kept. Whether it will be magnetized or not depends on the material. Iron, easily it will be magnetized. Aluminium, it cannot be magnetized easily because susceptibility is different. Now magnetic susceptibility is denoted by this Greek letter chi and M. Magnetic susceptibility is defined as the ratio of intensity of magnetization to the magnetizing field. Intensity of magnetization is denoted by the letter M. You take the magnitude of that. Intensity of magnetization is the dipole moment per unit volume. M is equal to Pm by V. Intensity of magnetization is the dipole moment per unit volume. You take the magnitude. Then magnetic susceptibility is a dimensionless quantity. Then for an isotropic medium, magnetic susceptibility is a scalar. But for non-isotropic medium, magnetic susceptibility is a tensor. I hope you have understood all the properties of the materials. Thank you for watching.